Okay, so the inverse trig functions. There's three basic ones that we use. We use y equals the inverse sine of x, which may also be written as the arc sine.
Will we see more?
You just need to know both. You just need to know both. Okay, so the arc sine is one of them. We're going to write information about these to the right of it. The next one is y equals the arc cosine. Well, arc cosine or inverse cosine. Okay, then there's the y equals, do I need to write it both ways for everyone? No, okay. So, no, I'm just going to write the arctangent of x. These are the three main ones. And then there's y equals the arc cotangent of x, y equals the arc cosecant of x, and y equals the arc secant of x. Okay, so for each of these we need to know the domain and range, because we talked in the beginning of the chapter, in 5.3, we talked about inverse functions. And the sine function, recall, if we just look at the sine function, it goes like this, it's wavy. And if you do the inverse, if you switch the x and the y around, then it's actually going wavy up along the y-axis, and that fails to pass the vertical line test. So if we just take the entire sine of x function and find its inverse, the inverse sine, it's no longer a function unless I limit the domain. So the domain for each of these we need to talk about, and then the range. So the domain and the range. And these are important because if you're going to find values, you need to know where to look on the unit circle to evaluate these. So this is not calculus. This is just a review of pre-calc right now is all this is. So when y equals the inverse sine, the domain is from -1 to +1. And that's the same for the cosine. -1 to +1. In fact, if you think about, here's the graph of the sine function. The range of the sine, the normal sine, is positive to -1. It had to fit in that strip from -1 to +1. So when you find the inverse sine, the domain and the range, so the range was -1 to 1, now it becomes the domain. The domain and the range of the regular sine functions are just flipping places, but the range, we actually had to limit. Okay, so the range of the sine function is from -π/2 up to and including +π/2. So that is, like if you're looking at a unit circle, that's this half of the unit circle that you can look on for values or answers for the inverse sine. For the inverse cosine, the range is 0 to pi. So for the sine, you can look at everything on the top half of the unit circle. Okay, so the tangent, arctangent, and cotangent, their domain is -infinity to infinity. Okay, so the tangent and cotangent, their domain, so you can put any numbers in for x values for the arctangent and the arccotangent. And that's because the graph of the arctangent and cotangent, they're kind of like little swoopies all along. They just swoop down or swoop up from left to right. And so that's the regular tangent. So if you find its inverse, then they're doing this kind of thing. So the domain becomes what the range was. Now for arctangent, the range, the values, the answers can come from -π/2 to +π/2. So it's the same as sine. You can look on that half of the unit circle. Okay, the arccotangent, you can only look from 0 to pi. So that's similar to the sine. Okay, the cosecant, its domain is the absolute value of x. The absolute value of x has to be greater than or equal to 1. So basically it can't be anything in between 1 and negative 1. X, like if this x is negative 2 would be there because its absolute value is greater than 1. Basically the arc cosecant and the arc secant have the same domain. And that's because the graphs of arc secant and cosecant are these, like little U's and hills. That's the regular secant, cosecant looks similar to those. So the domain was negative infinity to infinity, but the range was basically everything above 1 and less than 1. So that they switch places now. So then now we have to limit this so that it stays a function. So for the arc cosecant, the range is from negative pi over 2 to positive pi over 2. And the same thing for the arc secant. No, that one is 0 to pi. And now there's a couple stipulations here. Y cannot equal 0 for the arc cosecant, and for the arc secant, y cannot equal pi over 2. So these are basically just the definitions of all of these inverse trig functions. So if you wanted to see the graphs of these, I mean, we could make little tiny graphs here. The graph of the arc sine. Okay, so the graph of the arc sine, basically here's negative 1 and positive 1, and this is pi over 2, and this is negative pi over 2. The graph looks like this. This is the whole graph of the inverse sine. This is it, the entire graph. Because really, if you remember, it's going to be the whole sine wave going up and down, but we can't include that or it won't be a function. So the inverse cosine looks a little different, kind of not much different. There's 1, there's negative 1. This is up here at pi, and it looks like, this is pi over 2. It looks like this. The inverse tangent, this has, basically it's got a strip. This is negative pi over 2, this is positive pi over 2, and it goes like this. This is what the inverse tangent looks like. The inverse cotangent is very similar. It just looks like this. It goes the opposite direction. The arc cosecant, this is pi, this is 1, this is negative 1, and this is pi over 2. Basically looks like this and like this. And this can keep going. And then the arc secant looks similar, only it goes above and below. So here's 1 and negative 1, and this is pi over 2 and negative pi over 2. And it looks like that.
Look to it.
Hello. Okay, so here's what you really need to know about inverse trig functions. Inverse trig functions, this statement right here, y equals the arc sine of x. This is the most important thing that we've talked about so far. You need to understand what this is asking me. This is saying what angle. This is an angle. This is saying what angle. What angle, that's the y, has a sine value of x. What angle has a sine value of whatever this is? So this is the sine of what angle? So it's backwards on the unit circle. You're looking at the ordered pairs, and then your answer is the angle that goes with that ordered pair. So some of the first questions you will be asked to answer are questions like evaluate each trig, evaluate. So let's say I want to know the arc sine, the angle whose sine is -1/2. The arc sine. So first thing you have to be able to do is translate. What is this asking me? Evaluate. What does it equal? This is saying what angle has a sine equal to -1/2. And this is where you get your unit circle out. I don't know if I have a unit circle handy. I do. I have one in the front cover of my book, so we'll just look at that one. So here's my unit circle. What angle has a sine of -1/2? So here's my unit circle. It's got a bunch of ordered pairs. Which part of the ordered pair is the sine? The y value. So I just go around and I look at the y values. Now with the sine, I can only look here. I can only look on this half. That's why I went over the thing I did at the beginning. If you look back at this page that we wrote this down, here's the arc sine. I can only look on that half of the unit circle. That's it. So I can only look on that half, and I look for a y value of 1/2. Let's see, there, or -1/2. There it is. What angle does it go with? No. 330 is not how we give our answers. We don't give them in degrees, we give them in radians. And 11 pi over 6 is also wrong. It's -pi over 6. Because remember, your answer has to be between -pi over 2 and +pi over 2. So we have to use the negative angle names for these. So this negative is -30 degrees or -pi over 6. This is -pi over 4. This is -pi over 3. Because if we give the angle 11 pi over 6, that implies that we went all the way around, which we can't do. We can only name these positive and these negative angles for the arc sine. If this were an arc cosine, we could only look on this part, the top half. Okay, so the answer to this should be -pi over 6. Okay, keep your unit circles handy. Okay, so now the next one, number 2. What is the arc cosine of 0? The angle whose cosine is 0. Cosine is which value of the ordered pair? It is the x value. So for the arc cosine, I can look at the top half, and I'm looking for an x value of 0. Do you see it? At pi over 2. So the x value of the ordered pair is 0 right there at pi over 2. Okay, so this would be pi over 2. All right, now it's going to get harder. The arc tangent of radical 3. What angle has a tangent of radical 3? Okay, unit circle. I did give you a unit circle at the beginning of the year too, so you should have that. So now tangents are not on here. Now for arc tangent, where can I look? Top half or right half?
Right half.
Right half. Those are your only two options. It's the top half or the right half. That's it. So I can look over here, and the tangent, how do you find the tangent using the ordered pairs? Sine over cosine, y over x. So in which of these, if I take a y over x, will I just get radical 3? Well, it's got to be one of these three, right? How do I know it's one of those three? Because it's positive. That's how I know. Any of these will be negative. So here, it's definitely not that one because these don't have radical 3's. If I take this divided by this, the radical 3 will end up on the bottom. That's not what I want. But this is the one right here, pi over 3. So the angle whose tangent is radical 3 is pi over 3. Okay. Number 4. What if I wanted to find the arc sine of 0.26? Is that on your unit circle? Just your hunch. What do you think? On the unit circle, yes or no?
No.
No, it's not. So you're going to use your calculator.